In 1909, Ernest Rutherford performed the gold leaf experiment. And out of this experiment, we came to the conclusion that an atom has a nucleus. And we call that the nuclear atom. So let's talk about this experiment because it's a pretty important one with regard to the atomic theory. In this experiment, a beam of alpha particles, which are positively charged, was directed at a gold leaf surrounded by a phosphorescent zinc sulfide screen. Now, gold leaf can be rolled extremely, extremely thin. So basically what we had was a setup kind of like this. We had a lead block that had a hole drilled into it, and into that hole, bloop, we dropped an alpha source. So that in effect, as this alpha source gave off alpha radiation, the lead would block the alpha radiation from going in every direction except right here to the right. So then that beam of alpha particles was directed at this very, very thin piece of gold leaf. Around the outside we put a screen that was coated with zinc sulfide, and it would glow whenever it was hit by radiation. And so what Rutherford discovered was that you got a very constant glowing spot right there on the back of the screen. In other words, the alpha particles, almost all of them, went straight through this piece of gold leaf. But what was a little weird was that we would get occasional blips of green. If you watch the screen here, you can see these random locations where we're getting blips while the big glowing portion right here stayed constant. It glowed the whole time. Every so often we'd get bloop, green light, bloop, green light, bloop, green light in these various places. And that was because these alpha particles, some of them were deflected, just a little bit. This one was deflected a little bit more. This one here bounced almost back in the exact same direction. Now, what does this suggest about the atom? So Rutherford found that most of the alpha particles passed right through the gold foil, some angled slightly, and a tiny fraction bounced back. So from this, Rutherford concluded that, unlike what Thomson said with his plum pudding model, the atom is mostly nothing. It's mostly empty space. Why else would almost all of the alpha particles just go straight through? Secondly, he concluded that the positive particles that are in an atom must be concentrated at the center. So if we look at this picture, if we look at the alpha particle that's at the bottom of the picture, all right, I'm circling it with my laser pointer here, and it scoots to the right, it is a positively charged alpha particle, and it comes kind of close to the nucleus, but then is repelled because it is positive and the nucleus is positive, and so it veers from a straight line course. Same with this other one that veers from a straight line course. It kind of gets near the nucleus but not straight at it and just veers off course. Whereas this alpha particle that is in the center of the group, you can see it on the left here, I'm circling it with my laser pointer. This one must be headed directly for the gold nucleus. Now it doesn't hit the gold nucleus because the alpha particle is positively charged and so is the gold nucleus, so they don't actually hit, but it gets pretty close to the nucleus until that electrostatic repulsion kicks in and the positive alpha particle bounces out and is directed the other way. So that little nut at the center of the atom we call the nucleus. Just like there's a little nut in the center of a peach, we call it a pit. There's a little nut in the center of the atom, we call it a nucleus. Now, the negative particles are still there. Rutherford said, well, for lack of any place better to put them, they must be orbiting the nucleus. So let's go through our history of the atom so far. Let's review. This is the Greek model, and it's also Dalton's model. No protons, no electrons, no neutrons, just a BB, a solid chunk of mass, indivisible, unable to be split into pieces. Well, Thomson discovered electrons, which are negatively charged, and we also knew that the atom was electrically neutral, so there also must be positive charge. And Thomson said, okay, we have a large mass of positive dough and little electrons, negatively charged, embedded within. Now, based on what Rutherford has figured out, those positives are not spread out through the atom, like Thomson suggested. They're concentrated in a little nut, a nucleus in the center, and the electrons are orbiting around the outside. You can see now that this atom is starting to look like what we kind of recognize when we think of an atom.